Good day and welcome to the Fall 2017 CWRE workshop. This is Justin Iverson, the Groundwater Section Manager for the Oregon Water Resources Department, and I'm recorded here to provide an overview of the Groundwater Section's technical review of new groundwater right applications. So first of all, I want to put our technical review in context. This is a flowchart available from the department describing the full permit application process. The groundwater technical review is denoted here with this gold star. It is just one component of the initial review, which is itself just a component of the full application process. So I want to make sure to orient folks that our technical review is just one part of the process, and that there is a lot more input that goes into the full review of an application to get to a final order and a permit potentially. So when we conduct a technical review of a groundwater application, the review is based on the public interest presumption in rule. So the department shall presume that a proposed groundwater use will ensure the preservation of the public welfare, safety, and health if that application does four things. So first of all, the proposed use of water must be allowed in the applicable basin plan. We have to find that water is available for further appropriation. We need to find that water use or a new water use will not injure existing water rights. And we also need to make sure that the proposed water use complies with all the rules of the commission. So we assess these four public interest presumptions in a pretty methodical way. We do so by using this groundwater technical review form. So for anybody that's worked with groundwater rights in the past, this should be pretty familiar to you, and I believe this has been handed out for you to follow along as we step through the various sections in this groundwater review form. Now there are three main reasons that we use this form. First of all, it steps us through all the required assessments in rule and statute, so we want to make sure we don't miss anything. B, it keeps the various groundwater reviewers or the hydrogeologists conforming to a standard template. And B, it makes it easy for us and for you and the public to find specific pieces of information when it's consistently in the same format. You can always just skip to, for example, the last page to see what we think about well construction of existing wells that might be proposed as POAs on this application. So this form has four major sections. Section A is a place where we kind of rewrite down all the information pertinent to the technical review at hand and get everything in the same place in a concise format. Section B is where we address groundwater availability portion of the public interest review. So these are all the Division 310 rules. Section C is where we assess hydraulic connection between groundwater and surface water, our Division 9 rules. And Section D is where we assess compliance with well construction regulations in Divisions 200 through 230. So again, we're going to step through these sections in order. You can follow along on the form that you have there as a handout. So first of all, Section A, the general information section. Again, we want to capture the essential groundwater information that is assessed during the technical review. So we want to essentially take all the information from the application, all the pertinent information, put it in one place, and that way it's clear what we are reviewing. So we're reviewing a particular set of proposed POAs or wells. We are assessing particular use of water from a basin, an administrative basin, as well as a sub-basin. We're assessing seasonal use that might be year-round or for an irrigation season, so on and so forth. This lays out precisely what we're going to review, and I guess I'll state here that it's important when preparing an application that these items are all clear to us. We don't want to have to be guessing about well locations or uses or so on and so forth. So if you have an existing set of wells that you're applying for water rights on, that makes it a bit easier. You can review the well log and fill out all the information that's required in these tables. If you are proposing new wells, please give us as much information as possible, especially about the depth of the well in your target aquifer, so that we're assessing the correct aquifer. That will have ramifications for our answers further down the line. Similarly, please be sure that you're as specific as possible with the location of your wells. That, again, plays into the review and into some of the rules in Division 9. Alright, so this slide shows a screenshot of an ArcMap window. First thing that we generally do after filling out the table of the pertinent information is to plot the wells spatially so we can see where they're located and what's located around them. Going to be using a couple of recent applications as examples going forward here, and in general I'm going to be zooming in to just a couple sections to make it more clear what we're looking at, but I wanted to give you an overview of what this looks like to the hydrogeologist as they're sitting at their desk. So again, first thing that we'll do is we'll plot the locations based on the meets and bounds that are provided in the application. It's again pretty important that care is taken in writing these down so we get the wells in the locations intended by the applicant. Once we have the wells plotted, we'll start to look at other data layers and what's around. So this, for example, is a surficial geologic map for the area in the vicinity of these two proposed POAs, and from this information we will make a determination of the aquifer in which the wells are intended to draw water. In this case, we already had well logs for these two proposed POAs. We know that they're relatively shallow, and therefore that they are targeting the shallow alluvium of the Willamette Valley. As we go through this data gathering phase here in Section A, we're also gathering information that will be used in further sections. So this is just to let you know, this is C1. We'll talk about Section C here in a little bit, but in general, the data that we're drawing on and assessing is being used throughout the application to inform our decision. So in addition to saying this is shallow alluvium of the Willamette Valley, we know that this is an unconfined aquifer. We'll mark it there, and we'll give a little basis, a little narrative of the basis for our evaluation in the notes pages. Want to make sure to let folks know that we're not simply using digital data sets, though we try and digitize as much as we have for efficiency's sake. We are using pretty much any published report with pertinent information that's available for the geographic area that's subject to the application. In this case, these are examples of a Dogami report with detailed geologic mapping for a few counties of the southern Willamette Valley, as well as an example on the right here is a cooperative study that we conducted with the USGS to define the hydrogeologic framework of the Willamette Valley, 2005 report. Lastly, in Section A, we take a look at the basin and groundwater administrative area, any potential rules or restrictions. In this example, we've called out the Willamette Basin Plan as the governing plan, but then marked that the provisions of this plan are not activated by this application because the proposed wells are in the unconfined alluvium and we don't have any specific rules or restrictions on that aquifer. If this were a different example where the wells were targeting the Columbia River basalt a little bit further north in the valley, then that would have activated the rules, potentially depending on the geographic location. So this is a map of the location of our various groundwater restricted areas in the state. So again, if the proposed POA falls within these areas, we'll call out any additional restrictions that are specific to these areas. Okay, moving on to Section B, an assessment of groundwater availability under the Division 310 rules. You'll see that we take a look at a number of things in this section. First of all, we take a look at making an assessment of whether or not the target aquifer is overappropriated, whether or not the proposed use will likely cause injury to an existing water user, whether or not the proposed use is within the capacity of the resource, and then we identify any protective conditions we believe are necessary to ensure that the proposed use, if permitted, will be protective of the resource and the senior users. Lastly, down at the bottom we have a narrative. Again, we try to provide remarks about why we check the boxes we check above, so that the applicant and their agent can follow along with our reasoning. So in the example that we've used here, I want to point out that we've relied heavily on data from another permit conditioned observation well that's called out here with the red box, and you'll see that well in the coming slides and how the information that was gathered there played into how we made a decision on this subsequent application. So first of all, we want to plot up all the wells within the vicinity of the proposed POAs for which we have data. So this is our data coverage for this area in Lane County. And again, you can see with the red box this permit condition observation well that's located within a mile of the proposed POAs. We will then take the water level data that we have for this area and we'll plot it up on a common hydrograph. Again, I've called out that permit condition well. We can see that water levels here are relatively stable, and we have another well that has a record that goes all the way back to the 1970s. So in this case, looking at these wells dispersed around the aquifer, we would find that this particular aquifer is not over-appropriated. Water levels are stable, meaning that in general the use of the aquifer is being balanced by recharge. I want to give a counterexample just so folks can see what it might look like otherwise. This is an example from the Umatilla Basin. What some of you might be recognizing right now is that we have two different trends. So we have some water levels, these purple levels up at the top of the plot that are going around without declining, and then in the green, yellow, and black data points we can see significant declines of more than 100 feet or so over the decades. So again, an example given here is from the Umatilla Basin. We have a well in an overlying alluvial aquifer. That's the purple. Alluvial aquifer has relatively stable water levels. And then we have data points in underlying basalt aquifers, and we can see water level declines over time. In the case of the alluvial aquifer, we would likely say not over-appropriated. However, in the case of the basalt aquifers with these declining water levels, it's clear that the use is not being balanced by recharge, and we would say that that aquifer has been over-appropriated. Now, we have a series of additional tools that we look at. We look at summary statistics. This is a plot of range of static water levels, static water level on the y-axis here and individual wells along the x-axis. Again, this lets us know in general the range of water levels over the period of record that we have for each of these wells. And we also take a look at data from our well log database. So these are summary plots of data from well logs, in this case within a few square miles of the proposed points of appropriation. So for example, if we want to know, hey, where are wells generally completed in this area, we would look to the upper right plot. That shows well completion depth on the y-axis and frequency, or how many wells are completed at a particular depth. Here we can see that dominantly most wells are shallow. They're in the 20 to 40 foot range. So we can tell that this alluvial aquifer is the dominant aquifer in the area. Sometimes we might get a bimodal distribution where we have spikes at 20 and then spikes at 200. That would be indicative of two aquifer systems, and we would look to the information provided on the application to determine which of those aquifer systems the applicant is proposing to draw additional water. Okay. Moving on to the injury assessment, we would look at another GIS layer, this one of existing points of appropriation in the vicinity of the wells. As well, we've plotted spring locations on here, and essentially we take a look around in a mile radius at these other proposed locations and ask ourselves if the proposed application would likely create substantial interference. Generally look to TICE distance drawdown plots to assess what would the pumping interference be to nearest neighbors. In this case, the nearest neighbor is about half mile away or so, and we found that that would be negligible. Okay, and I want to give another counter example here. In this situation, we have a proposed POA sitting on a hilltop that is 3 miles or so from the nearest wells marked in green here, for which we have time series data. In this case, reviewing hydrogeologists might not feel comfortable projecting the water level trends that we see 3 miles to the north down across a drainage divide and up another hill toward another proposed POA. This might be a case where we mark the box cannot be determined, where we don't have enough information in the vicinity of the proposed POA in order to make a call on whether or not that particular aquifer is over appropriated. In this case, our general practice is to recommend monitoring and reporting conditions, so water level measurements with reporting as well as use. That gives us then a data set on which we can better assess the next application that comes in that area. I'll also say that just because we don't want to make that over allocation call based on the distance to data doesn't mean we have no data in that area. We still have a geologic coverage. We can still query the well log database for summary statistics of domestic wells drilled in that area, and if that information leads us to believe that the use can't be sustained by the aquifer, that's when we'll move down to that not within the capacity checkbox. So the not within the capacity assessment is really a forward-looking assessment, and given the data that we have and our professional judgment, do we believe that the aquifer can sustain the new use? Okay, we're going to move on now to section C. This is where we take a look at groundwater surface water interaction under Division 9 rules. Division 9 has a number of prescriptions for determining whether or not a groundwater use has the potential for substantial interference, and we denote that shorthand PSI. Finding a PSI opens up a groundwater use to review for surface water considerations. So if during the groundwater technical review we find PSI between a proposed point of appropriation and a surface water body, that will trigger the water rights section division caseworker to determine surface water availability and potentially request a Division 33 review from Oregon Department of Fish and Wildlife if salmon-bearing stream is found to have PSI with these proposed wells. So we use the National Hydrography Dataset as our base map for locating surface water bodies in the vicinity of POAs. And in this slide we have put a 1/4 mile radius and a 1 mile radius around those two POAs to see what surface water bodies are within those distances, as those have special meaning in Division 9. So returning now to the form, we have seen previously in this presentation section C1, where we've already determined that the aquifer that's targeted by these two POAs is the shallow alluvium of the Willamette Valley, and we've identified that as being unconfined. In C2, we combine, paragraphs 2 and 3 of Rule 40 of Division 9. We again identify the two wells. We identify that they are hydraulically connected with the Spring Creek. We do that based on geology, based on groundwater level elevations, based on whether a stream is perennial or ephemeral. And we note the distance between the well and that surface water body, and then give a narrative of the basis for our hydraulic connection evaluation. Okay, stepping down to C3A, we continue looking at the various Division 9 tests for potential for substantial interference. So we've identified here our wells. We've taken a look at number of surface water rights, and this is a different application than we've been looking at. 1 POA, 3 potential surface water rights within a mile. And we start stepping down all the rule-based determinations for PSI. So first of all, is your well within a 1/4 mile of a hydraulically connected stream? If you're hydraulically connected and within a 1/4 mile, even if you're in a confined aquifer, we will find potential for substantial interference. Secondly, we take a look at whether the requested rate falls within some thresholds that are again set out in Division 9. So in this case, you can see down in the comments the requested allocation was a 1/4 of a CFS. So first test is it greater than 5 CFS? No. If it were, there would be a PSI determination. Secondly, is the requested rate greater than 1% of the in-stream water right? We list the applicable rights and what the in-stream water rights are. In this case, again, the requested rate is less than 1% of that in-stream water right. Step over to test the rate against 80% of the natural stream flow. Again, we gather that information from the water availability reporting system, and we assess the proposed rate against the flows. And lastly, we take a look at interference from pumping at 30 days. We do that with an analytical model. I'm going to talk about that a little bit more here on the next couple slides, but first of all, just want to go back and show that the 1% of the 80% comes from our water availability reporting system from the natural stream flow column. So you can look up month by month what those flows are. Similarly, the in-stream flow requirements are also listed in WARS. So if you are preparing an application for a water user, you can potentially use your knowledge to assess whether or not you're in a hydraulically connected well, and take a look at those in-stream flow requirements and natural stream flow requirements yourself, and kind of do a pre-assessment of, is the rate that I'm asking for going to be compatible with Division 9 rules. And finally, to assess the rate at which the pumping of a hydraulically connected well will affect the flow of water to or from a stream after 30 days of pumping. That's the final test in Division 9. We use published and peer-reviewed analytical models. We use 3 common models that describe various system geometries, so how the well is related to the stream, and we use input parameters or aquifer parameters based on published values as well as values that come out of our pump test program to conduct this assessment and define PSI or not according to Division 9. So moving on to the final section, Section D on well construction. So we always take a look at either proposed well construction or the construction of existing wells. If somebody's applying for a new well, we want to ensure that we're protecting the aquifer from contamination and commingling. So we have a brief review here to make sure that the well meets current well construction standards. And if we find a potential issue, we'll mark that on this form and forward it to the well construction and compliance section to Joel Jeffrey. Just a real quick screenshot. This is from our original example where we had 2 wells right next to each other. Again, you can see these 2 shallow wells. They even call out, amazingly enough, consistent lithology down the line. So in summary, we take a look at a large amount of data when we make our assessments. We endeavor to remain consistent between applications within a particular area and across the state, and provide the applicant with a narrative that describes our thought process along down the line. And that concludes my presentation on the technical review process we conduct for new groundwater right applications. If you have any questions, you can feel free to contact me. My email and phone are up on the screen here, and I've provided Jerry and Dwight with a stack of my cards. I'll look forward to hearing from you. Thank you, and enjoy the rest of your course.